So we have a brief presentation now I'm going to provide you on national geodetic adjustments. And this describes some of what we talked about yesterday of how you link your international terrestrial reference frame through to a regional reference frame if you have one, and then through to national datums. And I'll take you through some of the steps and the processing that you can use that's done for each of these steps. And then we want to have a discussion about, want people to let us know what kind of data sets have you got, what position are you in within your countries, where are you stuck and you feel like you need particular help getting from that step to this step, so that we can have a talk about options on how you can resolve those issues, and also think about other types of software or training that you may need to help resolve some of those issues. So I'll start with it's a bit of an introduction that it covers a little bit of what we had yesterday. It's just a refresher. So when would you consider performing a national geodetic adjustment? When would you be looking to develop a new datum for your country? That's what we mean. And I gave the example to some people earlier today that I've worked with a lot of countries in the Pacific Islands, and they have a situation where in 11 of the 14 Pacific Island countries that I know of, they have a datum that was developed before things like GPS even existed. So they have a local datum. It's not linked with GPS or the ITRF at all. So if you see where my hand is, you might have a reference frame that's over here, and then there's a GPS reference frame which is linked with ITRF that's over here, and they're not connected. So if they've got their land cadastral management system over here, and then they've got GPS observations over here, if they're trying to map out the property boundaries of someone's house, they may end up looking like it's in the water because none of their data sets are lined up. So if you have a system already in your countries which is ITRF based, you're going to be pretty close to having those things lined up, but there may be a little bit of distortion or differences between them. But what we're talking about here is getting your national datum aligned with ITRF in some form. And this is the process you would go through to do that. So you can either do that if you don't have one at the moment, or if you would like to bring it up to being with the more current version of ITRF. These would be the steps that you go through. Some countries want to do it, as I said, because they're not even close. They're not connected at all. And other ones have geophysical reasons for it. Over time, the disconnect between the current datum and the latest version of ITRF might have grown due to geophysical processes, whether that be plate tectonic motion, whether it be subsidence in certain regions. The options are endless, really. But if you're trying to keep it up with a modern version of ITRF, that would be something else to consider. You may want to also increase the accuracy of the datum needed for emerging technologies. So the example that I gave you yesterday was Australia moving from ITRF 1992 to ITRF 2014, because between those versions of ITRF, there's a 9 centimeter height difference in the ellipsoid heights you get. So it's a significant change between two versions of ITRF. And so it was seen as being important that the height system in Australia reflected what you get from GPS observations. So they wanted to modernize and remove that 9 centimeter bias so it wasn't confusing for stakeholders. So here's the steps in how each of these systems are created. If you start by looking at the components on the left-hand side, you can see that to develop ITRF 2020 and develop the most accurate version of the reference frame from a global perspective, they take in information from very long baseline interferometry, satellite laser ranging, global navigation satellite systems, and DORIS. And the reason they do that is because they're complementary. If you want to develop the most accurate reference frame for the globe, you can use these complementary techniques and you'll get the best result. When you go down to the next step, if you stay on the left-hand side, all that we're doing there is adding extra GNSS sites. So you're creating a denser version of the ITRF in your region. And then as you go to the national datum, you can see that at that point, this is where you would come in as national authorities. You're in charge of your national datums. And at that point, you want to add extra information that is not included in a regional reference frame. So at the moment for Africa, it will include all your GNSS cores that may normally go into a regional reference frame. You would include all of those, plus any other GNSS data that you have that might be a lower accuracy, it might be campaign type data, it could be terrestrial observations, all the different data sets that you have that can all go into your national geodetic datum. And if you follow those processes, you can see how your national datum is going to be aligned with the ITRF because you're using information from the one above as you go through each step. So for most people, you don't have to worry too much about the creation of the International Terrestrial Reference Frame, that top level. That's done through people within the International Association of Geodesy, through the services that they provide. And so they choose when they want to have a new ITRF realization and the epoch with which it's aligned. When it comes to the regional reference frame, again, for most people, that is not something that you will be involved with in the determination of AFREF if you get to that point one day. Some of you will be, but this workshop is not designed to tell you how to build AFREF. That is extremely technical process that requires a lot of expert knowledge of using GNSS software in particular. That's not what we're focusing on here of how to develop that regional frame. What we're focusing on is how to use the outputs of ITRF 2020 or an output of a regional reference frame to create your national geodetic datum. So how do I take that information and what software do I use to create my national datum? That's what we're focusing on here. And that's what I'm talking about when I say a national adjustment. An adjustment is just a mathematical process where you put all your data sets into the software with the associated metadata. And the output of that process is the coordinates, velocities, and uncertainties of those ground marks that you have in your country. So let's look at a bit of an example here. If you think about this from a picture standpoint, the yellow circle may represent an ITRF or an IGS point. So you might have one of those in your country, and that's tying you and all your data and aligning your data with the International Terrestrial Reference Frame. The blue ones might be regional reference marks that in the future could be recognized within AFREF. And then the red ones would be the other ones. So as you can see, you have a lot of data in your countries that will not be being used in a regional reference frame, and it's not being used in the International Terrestrial Reference Frame. But by having the information from those three levels in your national adjustment, you can compute the coordinates on all those red crosses and make sure that all those red crosses are aligned with the ITRF, because you're going through and holding information fixed in the adjustment. And I'll explain what that means in a moment. So here's an example of the regional reference frame for Asia Pacific from Australia. So let's have a look at what this actually means in detail. For some of you, you could even look at this as your national data sets. Without a regional reference frame, you could say, these are my high quality national data sets that I want to include in my national adjustment to define the datum in my country. We're talking about continuously operating reference stations here. There are 726 that are in total across APREF. And for our national datum in Australia, 488 of them were found to be on the Australian plate. So they are the ones that we use in our datum development in Australia, the ones on the Australian plate. And as you can see, there's a lot of detail here that we're capturing because only 15 of them were used in the determination of ITRF. So it's a lot of extra information that we can use to improve the definition of the Australian datum. I'm just trying to figure out if I want to cover anything else on these dot points, sorry. I think that's okay. There's a lot of details there in terms of the steps that you go through, but we don't need to cover that now. I don't want to overcomplicate it. This looks fun, doesn't it? So if you go back to this one, you see these are the GNSS cause stations. And then these ones are that next level down that I was talking about. So these are all the extra data that they're not continuously operating reference stations. You can see that these are more campaign observations where you've been out into the field and you've collected more than 6 hours worth of data. That was a limit that we set because we thought that's still good quality data we can include in the national adjustment. So this was all the data that was collected by Geoscience Australia over a number of years. And it's 6,092 different stations, which creates over 11,000 baselines. So if you think about a baseline, for those of you who haven't done processing, all it is the connection between two survey marks. So when you go out into the field, you'll often set up a GNSS station, but you might set up 10 or 15 and you do them all at the same time. Because if you process all the data, if it's collected at the same time, a lot of the errors in GPS processing related to the atmosphere at the time, they drop out because you collected all that information at the same time. So it's really useful to do these campaigns in groups. So this shows you the history of how all that data has been collected and the baselines or the imaginary lines between all of these stations around Australia that were put into the archive. You can see that some states decided to only include certain information from their jurisdictions. And that's because they didn't think that the other information was of the right quality to include, or they didn't think it would add a lot of value, or they didn't have the right metadata that was required to run it through the processing. So that's why you get this strange mix of stations throughout Australia that were included at that lowest level. So what do we do with all this data? Where does it go? For us, it goes into this process. And this is also another type of more technical training that we would like to provide into the future. But I want to walk you through this process of how you do a national adjustment. So how do I bring all this data together to define the coordinates, velocities, and uncertainties of the stations in my country? And it's called in ours, it's an adjustment approach, and it's fully automated. So the software we use is called Dynadjust. And Dynadjust, I've got a link at the end, is open source software. So anyone can get it, anyone can access it, anyone can use it. And it is able to do continental scale adjustments. It handles all of the Australian data. It's about 3 million observations, I think we have included in there by the end. It can also just do a cadastral survey. You can just include a very small parcel land and do your adjustment of a very small piece of land. So it can handle everything. So it's therefore a software that I recommend because it's open source and you can learn it once and then apply it to a whole range of different surveying and geodesy requirements. It's also got a very good user guide and manual that you can use to follow. And it was developed, it originally came out of Melbourne University, and then it got rewritten in more up-to-date language, and a more definitive user guide has been developed for it, predominantly by a gentleman called Roger Fraser, who works for the Victorian government in Australia. And he did a lot of this as his in-kind contribution, and then he gave the software away for free, which I think is a fantastic thing. So it's all in a GitHub repository, and I've got the links for that at the end of it. But let me take you through the steps of how this works. So the start, you importing your data. So I list there that you're importing your SINEX files, and I'll explain what that is. GNSS baselines, terrestrial measurements, and leveling. So what I'm saying here is you're bringing in all the data from that highest level of those definition points from ITRF, or it could be your AFREF that you put in there. You're bringing in that next level of information on those baselines that were the 6 hour plus type observations or terrestrial measurements in your country. And you can also bring in your leveling data. So that's import all your data, import everything that you've got. The next stage that it does is it aligns all the stations and measurements to a specific epoch. Because if you're going to run all these different data types that have been collected over different years, you need to have them all sitting at a consistent epoch. And you can choose what epoch that is in the software. And then in the background, it applies datum or reference frame transformations to move all that data into the same frame of reference. So in our case in Australia, it was at ITRF 2014 at 2020. That was our reference epoch, 2020. In cases where you don't have the transformation parameters, it falls back to using the ITRF plate motion models. So there are some ones that have been developed that work at a global scale. They're not as accurate as local ones you may develop, but there are global models out there to transform your data into a consistent epoch. The next stage it does is it takes any of your data that's leveling data, and we'll learn a bit more about this tomorrow, but for those of you who've done a bit of physical geodesy, you know your height datum. So your heights with respect to the geoid or with respect to sea level, they're not the same as the height with respect to the ellipsoid. There's an offset there. And sometimes that can be tens of meters, 50 meters or something. So you need to take the orthometric data or your mean sea level heighted data and convert that to be something with respect to the ellipsoid, because all the computations in the software are done on the ellipsoid, and then you can output it again with respect to a geoid model or with respect to sea level, whatever your height datum is later on. But all the computations need to happen on the ellipsoid. The next stage it goes through is it breaks it up. It looks at the network and it says, right, if I've got all of this different data, how can I segment this and run it in the most efficient way possible? For smaller data sets, this is not really a problem. But for big data sets, for those of you who've done least squares analysis, you know that there's an inversion matrix and it grows and grows and grows. Every piece of data you add, that inversion matrix grows and it becomes very, very difficult to solve. But what this does is it takes common points. So it might, let's say there's one grid here, one grid here, one grid here. It takes a couple of points from those and uses them across the different grids as it breaks it apart. So it means there's a consistency when you get out your, they call it a rigorous variance covariance matrix. So it means once you get the results out, the uncertainties are rigorous. They're not estimated. They're actually a rigorous assessment of uncertainty. That's the real key of what DynaJust does that maybe some other types of software can't. And that's why it makes it very suitable for the development of national datums, because you want to define the uncertainty of those coordinates as best you can. So here's what it looks like when you throw all of those different data types together from the Australian situation. And it looks like artwork that my son did when he was about 3 years old, but it's a wonderful collection and shows the historical data archives that have been collected throughout Australia. And you can see there that we're talking about all different types of measurements, the geodetic azimuths and astronomic azimuths that maybe you haven't done in your country in tens of years, but you've still got that historical data. And in some cases, it may be the only data type that connects two places. And if that's the case, use it, because it's a really valuable contribution. The key in using the data, though, is estimating what the uncertainty of that data would be. So if it's old data that was collected using a specific technique that is not very accurate, just put the uncertainty of this measurement was 1 meter or 10 meters. Then it won't bias your adjustment as you're throwing all the data together, but it's at least in there and it helps you refine the coordinates for any of those points. And then it goes down through all your traditional data sets like slope distance. That could be with a total station, which would be a lot more accurate. And then you've got the GNSS baselines and your leveling data, as I mentioned before. So you can put all this into a 3-dimensional network adjustment. So here's a bit of information about the software. DynaJust, you can see down the bottom there, there's a GitHub link. For those of you who haven't used GitHub, it's a repository where you can get access to software. And here, the ICSM refers to Intergovernmental Committee on Surveying and Mapping. That's a group of the states and territories in Australia, along with the federal government, who work on geodesy and surveying together. And then /DynaJust, and that's the name of the software. And you can see that there's the user guide there with credits for Roger Fraser, Frank Lay, and Phil Collier, who all came out of Melbourne University and have worked on this over a number of years. The thing that impresses me most about this is we got a phone call from Esri. Many of you will know Esri. Esri were having trouble with their land parcel management system. And they were having trouble defining the cadastral boundaries when they had so much information in there that they couldn't do an adjustment anymore. The software that they had that was proprietary wasn't working anymore. So they got in contact with Roger and said, how do you feel about us using Dynadjust in the back end of the Esri software so that we can offer better land management parcel information? And he said, that's fine. And he trained them up. He taught the Esri staff how to build Dynadjust into the land management system in Esri. And now that sits in the back end. So if you're using Esri for some of your land parcel management, Esri has effectively created tools and a better user interface, because Dynadjust is still at the level you've got to put it in, type it in using with a terminal. But Esri has a user interface. So for some of the land management packages, it's running Dynadjust in the background of its software.
For free?
For free. Yeah, I know. Geodesy, we give everything away for free. That's the problem. So here's some other resources and things if you're trying to understand where all these steps come in. So that GNSS analysis that I mentioned, that's using Bernice software that we've used. Or you can use OzPOS, and we've got links to Opus, as we mentioned yesterday, from the US as well. The combination software is called CatRef, if you're trying to understand some of this terminology. There's a link through there to the geodetic adjustments with Dynadjust. And then I found some great training presentations. There's a full presentation that goes for 1 hour and 42 minutes there on least squares. So even for those of you who've been through and done some least squares adjustment, that's the mathematical modeling of how you do this national adjustment. Even if you did some of that at uni, you're probably like me and you've forgotten a lot of it. There's some really good training videos out there. This one in particular, I'd recommend to have a look at. And then I've broken down some of the chapters as well, like what is it? Why do we iterate our observations? How to weight the observations? That's where I'm talking about what kind of uncertainties do you assign with your data, depending on its quality. That's called weighting. And then how do I constrain it? And you'll remember constraint, I was talking about, we constrain ourselves to ITRF. That's how you would be doing it, I think, for some of the national datums that you're working on. And then there's a question and answer session as well on YouTube, where we've looked at some of the common questions we get about working with Dynadjust and getting that set up. So I'd recommend, if you're trying to do this at a national scale, have a look at those videos and work through those first. And then if you've still got some questions after going through this material, let me know and I can give you a hand as you're going through that process of doing your national datum development. And if I can't answer it, I can put you in touch with Roger or Phil or someone like that who's very knowledgeable when it comes to this, and we can give you some more advice on how to go through these stages of doing the national datum development. So I'd like to stop there, and I'm happy to open it up for questions. We've got about 25 minutes before we break for lunch. And I'd be interested in if you've got any questions on this that I can provide you with more information about, that's fine. Or if you'd like to tell us about what position you're in at the moment in your country, and do you feel like you're stuck on one of these steps and you may need some assistance? It'd be good to know where you're getting stuck and where you think we could provide you with more help. All right, thank you. I'm happy to open it up. And Bruno's got his hand up already. Over to you. Thanks.
Thank you, Nick, for the presentation. I don't know whether moving forward to tomorrow, but I think I should introduce this. In the first presentation in the morning, we saw that Australia was having the normal orthometric heights. In this presentation here, I see we are talking about the orthometric height. How did we move from the normal orthometric to orthometric? Did you do some gravity measurements to do the conversions? Please guide. Thank you.
No, thank you. It's a good question. So I deliberately put orthometric here because it's a more general term. But the country may have either orthometric, it could be dynamic heights, It could be normal orthometric heights. There's different height systems. So it really doesn't matter what you have in your country. You could put in whatever you like here because you also need to feed it the geoid model. So if you put in the height and then whatever model you use to convert from that height system down to the ellipsoid, that's what will be used. So if we use an example of, I was talking to our friends from Rwanda earlier, they use EGM 2008. EGM 2008 is already built into Dynadjust, so you don't need to give it that file, but the heights that they put in would be their heights that are above EGM 2008. So you could call that a geoid height, an orthometric height, whatever you like. All you need to make sure is that the height that you're putting in is with respect to whatever model you tell it to convert down to the ellipsoid. Okay.
I wanted to ask how a geoid, maybe like for us in Uganda, we have UGeoid 2020 that is being used. How can it be added to Dynadjust? That one, yeah.
Yeah, great question. So you can add in your own models, which is good. So the international ones are already in there, but if you've got your own local ones, there's an import function. So you can import your geoid model in a range of different formats, and then you can call on that geoid model in the software. So it allows you to personalize the way that it operates.
Merci,
Thank you very much for the presentation. We've understood the alignment, and this is really well presented. And I take our example of a real challenge. We want to modernize our network and to go to ITRF to facilitate regional international cooperation, but we have some issues with the land system because they want ITRF. There is an impact on their database and the existing system. Shifting to the new ITRF, would it have a problem with the land registry and the existing information systems?
Yes, I can understand that would be a big problem. This is a good example where it's not a technical problem that we face. It's a communications and information sharing problem. But having said that, I think it's an excellent example of the challenges that we face in modernizing. So in this particular case, if you would like some advice or assistance to explain the purpose and the importance of doing what you're proposing, please get in touch with me and we can help you with that messaging so that when you're talking to a specific audience, you can explain it to them in language they understand. So I have some examples that I could share, and I could also help you gather other examples you could share to explain that. Yes.
Voilà, merci beaucoup.
Thank you very much. I had a question, but before getting to the question, I have an observation, rather, to come back to what my colleague said. It is one of the challenges that we will have in Africa. Today, we're talking about modernization of ITRF, and the situation we have in Senegal is that others want to modernize, might have the same problem, because what's happening today in Senegal, today we have a 2000.5, and we're looking at active network, which would enable us to recalculate the existing network. But for the moment, what is asked of the company that is modernizing this is to calculate two solutions, network 220 and 2000. So we need to find a solution. So the two options are either to take advantage to go to ITRF 2020 and to be in line with the international systems to facilitate integration and project management when cross-border projects. But the other challenge, like he said, is local actors. For example, land management. People already have their cadastre system linked to ITNF 2020. So if you do the shift, you need to make some adjustments to enable them to make the shift. But now the challenge is the harmonization and the consistency of databases. So the precision of it. So it is a challenge to have the parameters to do this transformation for all the information systems for geospatial data. So there's a real challenge, Senegal, but I hope other African countries will have the same problem when it comes to modernization. And then your software to Senegal, and I think it is the other problem with other Francophone countries. We are using software, and it is an altitude system, which is orthometric, but the reality is different because the altitude that were given leveling, at least on the documentation, they don't calculate the real altitudes to get rigorous automatic altitudes. So today, we need to do precise calculations. So often what you use is OGM system to try to adapt it. In this kinds of situations, would the software help us to correct this? Because with a grid like that, we could use that software. Thank you.
The good thing that the software will do is it will assist in helping you identify where there may be weaknesses in your data. So as you're going through the adjustment process, it highlights when you add data where it doesn't fit with other data types. So it's good that you're bringing data in from different data types. I would advise that you, particularly with this orthometric data that you have concerns about, I would bring that in with another smaller set of data and check how well it fits together. And the software can help with that. And then it will tell you whether or not the two different data types fit together. And if they don't, well, you know, then there is a problem with either data type A or data type B. So I would put in a data type that you trust, or maybe resurvey an area, a small scale area, so that you can trust the input observations, and then put in the other data set, the historical data set, and figure out which bits don't fit well together. It might help you identify the uncertainties on the original data set. And then you can include the original data set, but loosen the weighting and sort of increase the uncertainties of that data so that it's not trying to constrain it too tightly in the adjustment. This is a particular technique that you can go through, and it's a very specific type of way of interrogating your data. So again, this is something that if you would like, I can provide you with specific guidance on how you could test this using the software. You go, and then we'll come over here. Yep.
Ok, merci Diouf pour ta préoccupation.
Thank you, Diouf, for your concern. Just for feedback from Cote d'Ivoire, we're working on it. So three things. The first one, this emphasizes the need to think through the TORs before recruiting a company to do this kind of work, because the questions that you are raising should be addressed before signing the contract. But if the problem is there today, you need to renegotiate an addendum to the contract to talk about the second aspect that I'm talking about. We're not forced to migrate all the legacy data on the new system, given the cost and the timelines, etc. So text should, a legal document should impose the new reference to give grace period to migrate legacy data. And in the intervening period, you will develop an in-house solution to migrate data into the new system. The third thing where you have a problem with the cadastre, it is not the geodesic reference. It costs money. And generally speaking, we have problems, but UPM, you have trainings on that, and they lose a lot of money. So we need to discuss with them so that beyond this, you have a cartographic representation which will meet the needs of the different parties. That is what I would recommend. We did it in Cote d'Ivoire. We've not finished. It was a long, drawn-out work, but it doesn't stop you from starting. Thank you.
Merci beaucoup.
Thank you very much to the presenters. In Mali, my country, wide-scale sensitization campaign was done to bring all these geographic actors to this new system. And this policy recommended, first recommendation rather, to adopt one single system. In 2023, the government adopted for the whole country national geodetic reference GRS 2020 for the whole country. The second challenge that we ran into was that the old data that we had were in other reference systems, and we needed to bring all that data in the new reference system. The government, because our role was to come up with the national geodesic system. The government did not have means to do this, and they came up with some kind of levies for this equipment. The other problem is that we're working with actors, so you need to densify the network. And we got to a point where we started working with reference points. There are lots of divergences, and the question we asked ourselves is that, can we try to find technical assistance to observe these points, or we do it ourselves? So we said that for a first quotation, we need to have technical assistance for the first observations. So we are stuck. We have not managed to get the assistance. So the question, we are here among countries, and I think experience sharing will enable us to move forward. The other concern that I saw in the presentation is the software that I saw, which will enable us to transform the heights. And the question I ask myself, the countries that have done this, Australia, for example, the ellipsoid, not ellipsoid, the software, did it take into consideration the transformation in Australia, or it is a software that can work for any country's software rather? Is it a global software that any country could use, or it is Australia-specific software? The other concern is the transition to move from the current network to move to ITRF. And I think my colleague from Senegal, I think, has already talked about the challenges, because even having the network was problematic with other actors. If you're going to move from this reference to move to another one, I wonder how we're going to do it. But here among countries, and the experiences of other countries, we were to help us. And that is the Malian experience. Thank you.
Thank you. Just in response to your specific comment about the software, it can be used globally. It can be used in any country. In answer to the other questions, I think there's a lot there to unpack, and it shows that you can't just do this as your mapping agency on your own. You need to be engaged with the stakeholders. And we will talk about this in more detail this afternoon when we look at the roadmap, and you start thinking about the roadmap, and you realize that the technical part of the roadmap, as I showed you yesterday, doesn't start until step 6. You've got 5 steps to go through before you start doing anything technical. And if you are a technical person, the first thing you want to do is find someone who is very good at communicating, because you're going to need them alongside you for the first 5 steps at least. But we'll talk about that in more detail this afternoon. All right, so we've got a lot of hands coming up here. So we've got about 7 minutes until lunch. So I'm going to go 1. Who? No, you point. I'm out. You go. Everyone has 30 seconds. 30 seconds. Go.
Okay. I'm Levi Tambo from Zambia. I just wanted to share our experience. We have a lot of we're struggling to fill in that form, because it appears like this Australian example is assuming that you're using GPS and satellites to establish your datum, but ours was based on triangulation, and so we have a challenge of now linking the legacy trigonometric stations to these new global and regional systems. There was an attempt to do measurements over about 41 trig stations, try and create transformation parameters with WGS 84, but we've got thousands of others. So the advice is, what would be the process to handle the remainders? Including them in the system. The other question I had was the DynaJust. Does it perform the same functions as Benis? Would you highlight the differences?
I'll catch up with you in the break, and I'll explain it in detail. Okay. Any other quick comments?
Yes. Thank you. This is okay. Wow, thank you. I wanted to give just the Ugandan experience, because it has been a long journey. Started way back in 2008. And then we established the first points in ITRF 205, Epoch 2010. Once we had them, we had to look for the existing legacy or trig points which had been established in the other old datum. We managed to develop transformation parameters. They may not be as accurate as we want them to be, because some points had been destroyed, but then we were able to now move our land information system, the new ITRF. That's once we had the transformation parameters. Then once we moved the land information system and the existing cadastre based on the new transformations, we were able to densify the passive control points in ITRF. And then later we had to enhance the active. So I think it, as Nick has said, it is a process. You can do it. you have just to make a decision and say at this particular point we have to migrate, because like now we at least we have reached a point where we are telling all surveyors that now all data that we are collecting must be in ITRF. Interestingly, is we are still in 2005, but we have observations even of ITRF 2020. But because our transformation and the time we established the new land information system was in ITRF 2005. So we are thinking, how do we migrate all that data again and so forth? So we are still in the discussions. Thank you.
Thank you. Any other quick comments? Yes.
Okay, I'm Samir Ibrahim from Nigeria. It's just kind of curiosity that I think our discussion has been focused on XY, to me, on Z, and Z. Based on the form that you have given to us for the fact in our respective countries, the physical, the height datum, it's like, I don't know if there's any provision or later a kind of proposal or document that will guide people to develop it, because I notice most of the countries doesn't have kind of height datum information. Thank you.
So do you want to know if it's in the fact book, or do you want to know if guidance on how to do it?
Guidance on how to do it.
You're going to really enjoy tomorrow, Wednesday. We talk a lot about height datums, geoid models, and things like that tomorrow, okay? Excellent. Thank you. Good question.
Yeah, thank you. I think for Kenya, we have the same experience as Zambia, whereby the network that we have is the legacy one, mainly the triangulation. But these triangulations were not adjusted as a single network. Therefore, when you move from one network to the other, there's no agreement. So my question is it possible to apply the grid transformations, but is it necessary now with the new technology to do that? Or we basically do a new system based on ITRF and now ensure that all the surveys are done in the new system? Because again, working on these transformation parameters, we notice that they introduce errors. For example, in Nairobi now we have a digital cadastre, but we have overlaps and gaps because of applying the transformation parameters. Thank you.
You can join the lunchtime session. I'm going to draw it up on the paper down there. We'll look at these particular examples and I'll work through it with you, okay? Last.
Okay, merci beaucoup.
Thank you very much. I'd like to speak to what our Senegalese colleague talked about when you're talking about the height and the automatic height. The leveling in West Africa is autometric. We have a gravimetric 53 and 54, but it was not used because the relief of the region is not adapted. What we used as a solution in Burkina Faso was to recreate a national network with this NGO system to have a dense network and then to do a selection looking at the levels so as to find how this works on the national territory. And then the last phase where we are at is how to adapt the model that we have today by using this to have a local solution. So this is the option if you don't have the possibility to do a gravimetric network. You can adapt what you call the global models. We looked at the variances in West Africa because you have values to do the conversions. And when you compare with the levels, we have variances of more than 7 meters. So we try to understand this, and we don't have absolute points in gravimetrics. So we tried to look for it, and there's no absolute point. And what was done in 53 and 54 for the network is relative. So it is relative gravimetric that was used. So that is why we need to work on this at the local level. Lastly, on the cadastre, it is true you need communication. The problem is always there because if you have built a network of permanent points, there's a lifespan. You need to re-update this. You're going to recalculate the network, and the problem that you have is that when you do recalculation, you look at the closest epoch. So what should you do with the data that you produced before? So this is a fundamental aspect, because when you look at the cadastre, like Mr. Ballet said, it is a problem. Thank you.
Sorry, I'm just conscious. We need to stop at midday because we need to let our interpreters have a rest. So we'll stop there. Thank you. We'll be back at 2 o'clock for the next session. I hope you enjoy your lunch. I look forward to seeing you back here in 2 hours' time. Thank you very much.